Hi, this is Patel. In this lecture, we are going to look at the concepts regarding the principal stresses and strains, along with its introduction and some basic concepts required to understand the chapter concepts thoroughly. So let's get started with the theoretical parts of the principal stresses and strain. So first of all, we need to understand the definition of the principal plane. So how do we define the principal strain? So whenever a body is subjected to any kind of the stress or the strain, then that particular body is observed with that there are three planes mutually perpendicular to each other and which carries the direct stress only. There are no shear stress acting on that particular plane. So a little consideration will show that out of these three direct stress, one will be the maximum, other will be the minimum, and the third one will be the intermediate between the two. These particular planes which have no shear stress are known as a principal planes. So this is the basic definition of the principal strain. So in short, what can you write whenever it is asked for the 1 marks? So you can write down that a plane on which the direct stress, or it is also known as the normal stress, is acting is called principal plane. Now this definition will help you to gain the proper marks. What you also need to remember is on the principal plane, the shear stress tau is 0. So you have to keep this in your mind that shear stress value on this particular plane will be 0. So what could be the principal plane? It could be a horizontal. As you can see in your diagram, that this is the horizontal diagram of the principal plane, where this is our plane and this is our direct stress or the normal stress. That's why it is our principal plane. Whereas on the right hand side, you will see that there is a vertical plane on which direct stress or the normal stress is acting. So this is also known as the principal plane. Also, if it is an inclined plane but it contains the direct stress, then it is known as the principal plane. Now, what is the importance or characteristics of the direct stress? That we all know, we have already studied the direct stress in the previous chapters, but I'm just recalling it so that you guys keep this in your mind, that direct stress or the normal stress are always perpendicular to the plane. So if I draw here, then this, if you can notice over here, then this stress is perpendicular to this plane. Again here it is perpendicular, again here also it is perpendicular. So plane and stress both will be perpendicular to each other. So this is what you need to understand. Now we will move forward to our next definition, that is principal stress. What do we mean by principal stress? Principal stress is the magnitude of the direct stress across the principal strain is known as the principal stress. The determination of the principal stress and the principal plane is an important factor in design of various structure and machine component. So this is the basic definition of the principal stress, the magnitude of direct stress across the principal plane, that you have to keep in your mind. Now, what are the principal stress or how they may be classified? So as you can see on your screen, there is a 3 classification we have done on your screen, that the major principal plane, the minor principal plane, and intermediate principal plane. The major principal plane, the name itself indicates that it carries the maximum direct stress. So that is why, as it is the maximum, we have named it as a major. And minor principal strain, as per its name, carries the minimum direct stress. Intermediate principal plane carries intermediate, or we can say that medium direct stress. So this is how we have classified the principal planes. Now we are going to know or understand the methods for the stress on an oblique section of the body. So in the practical condition, we are taking generally an oblique section. What is an oblique section? A section or the plane at some angle, at a angle. So that angle might be anything. If it is 0, that plane is horizontal. If it is 90, that plane is vertical. And if it is anything other than the 0 and 90, then it might be the inclined plane. So oblique section is a very general term. So what we are going to do, we are going to understand the methods to calculate the stresses on the oblique plane. Now why do we need this type of methods to understand? Because we don't know that which plane will work as a principal plane. In your body, there might be a vertical plane, there might be a horizontal plane, or there might be an inclined plane where a shear stress value is 0. That will be our principal plane. So principal plane could be anything. We need to find out its location, that its angle, as well as we also need to find out the value of direct stress that is acting on that principal plane. So it is very important that we understand how to calculate or how to find out these values so that we can solve its examples. So there are basically two methods. The first one is obviously an analytical method, and the second one is the graphical method. So in this chapter, we are going to understand the analytical method. We are going to understand only the analytical method. In the upcoming chapter, in the next chapter, we will understand the graphical method, which can be utilized using the Mohr circle. So Mohr circle is our graphical method. So what is analytical method? Analytical method is anything that you calculate on the paper using the basic theorems or concepts. So whenever we use some formula, whenever we derive a formula for a particular condition and use it in the application or the practical use, then that calculation, or we can say that the answer that we get using that formula is derived or is gained through analytical method. So what we are going to do next, we are going to derive a formula for different cases. Firstly, I will derive a formula for the simple case, very basic case. Later on, we will see a derivation for the general case where the body could be subjected to any kind of a stresses. So on your screen, as you can see, there is a body which is subjected to a direct stress in one plane. In one plane, or it might be asked that in one direction. So in here, we have taken the horizontal direction in which the direct stress is acting. Now, what we are going to do, we are going to find out the normal, tangential, and resultant stress on an inclined plane. Again, it doesn't have to be inclined plane. It could be a vertical, it could be a horizontal, or it could be at any angle. But in general, if we can derive an equation for an inclined plane, then it could be used for any plane, whether it is a horizontal, vertical, or inclined. So we are deriving an equation for general case, for the general case. First of all, what stresses do we require? We require a normal stress. Normal stress is also represented by sigma. Sigma normal, that's why sigma n is the representation of the normal stress. So in our body, we will take randomly an inclined plane. So let me just explain you the diagram so that you guys can understand. Here is our body, a rectangular body ABCD. Rectangular body ABCD, which is subjected to horizontal stresses. As you can see, this is our ABCD body, which is subjected to horizontal stress sigma. This is applied externally, so we don't have to use our mind to understand it. It is applied externally, or whenever in the application they give you the force. This is the force which they provide. Later on, what we will do, we will calculate our principal stresses, or we are going to find out the normal and tangential stresses for any inclined plane. So this is our inclined plane. Let's say this plane is EF. EF is our inclined plane, which is at an angle theta, as you can see in your diagram, at an angle theta, and we are interested in to find out the normal stress. Normal stress is the sigma, and tangential stress is sigma t, and resultant stress is sigma r. So resultant is the resultant stress value of normal and tangential. So we will just list out the parameters that we are going to use for this derivation. So the first one is the sigma. As you can see, it is the normal stress acting on the body, which is externally applied, and we don't have to use our mind to understand it. EF is the inclined plane on which we are intended to find out the normal and the tangential stress. Theta is the angle of inclined plane with the vertical. It could be the angle with the horizontal also, but here we have taken it with the vertical. The sigma n is the normal stress on the EF plane. Sigma t is the tangential stress on the EF plane, and sigma r is the resultant stress on the EF plane. So let's understand the method, how to derive these equations. So first, what we are going to do, we are going to find out the tensile stress on the BC plane. Where is the BC plane? Let me just remove the annotation so that you guys can understand it. Okay, let me use one annotation pen. Okay, this is our BC plane. This one is the BC plane, which is vertical, and the stress is acting perpendicular in the perpendicular direction. So sigma is equals to force upon area. That is the basic equation of the stress that we have studied in a multiple times. So now what we are going to do, we are going to find out the tensile stress on the EF plane, because that's what we need. Instead of the BC, we need a EF plane. So EF plane is over here, as you can see. This is our EF plane. And now what is required is we are going to use the same formula. What is the same formula? That is sigma equals to P by A, or force upon area. Now what is the force? Force is the same that we have applied externally. The next thing that you need to understand is the area. Now we have taken the area of BC. BC is the area that is vertical. Now let's say it has the area A. Then the EF plane is inclined, so its area might be different. So how can we find out the area? By using this triangular pattern or triangle and geometry. We know that theta is over here. So if we apply the cos theta formula, then cos theta is nothing but adjacent side upon hypotenuse. So cos theta, let me write it down over here so that you guys can understand. Cos theta equals to adjacent side is equals to BC divided by EF. Hypotenuse is EF. So if we make EF as a subject, then you will get that instead of BC, A divided by cos theta. Instead of cos theta, we can write sec theta. So EF equals to, EF or the area is equals to A sec theta, or also we can write it A upon cos theta. So our formula would be sigma cos theta. That's our tensile stress on EF. Now this is the tensile stress, that is not equal to a normal stress. So first of all, we need to find out similarly the force perpendicular to the EF plane. So as we have seen the stress value, similarly we can find out the force with the same method. Force, it can be directly written as P cos theta. Now the normal stress on the EF plane. Normal stress on the EF plane is written as sigma n. So you are using the same equation, force upon area. Force is P cos theta, area is A sec theta. So instead of sec theta we can write cos theta over here, and our equation would be sigma n equals to sigma cos square theta. That will be our final equation of normal stress. Now tangential stress that we require to find out on the EF plane. So tangential stress act in a tangential direction like this. This is the tangential direction. So we are intended to find out the tangential stress. So first of all, we need to find the tangential force. So as it is perpendicular to the normal force, we can write it down over here as a P sin theta or P cos 90 minus theta. That will give you the answer as a P sin theta. Area is still the same. Area is of the EF plane. So instead of area, we can write down A sec theta. So instead of A sec theta, you can also write it P by A sin theta into cos theta. Now we know that using our geometry, 2 sin theta cos theta is equals to sin 2 theta. So here there is no 2, so we can multiply 2 and divide it by 2, so that we can convert this in terms of the sin 2 theta. So our final formula would be sigma t equals to sigma by 2 sin 2 theta. So this is our basic formula of tangential stress acting on the inclined plane. But we need to find out the resultant value. So resultant can be found using this formula, under root sigma n square plus sigma t square. So this is how we calculated 3 different stresses acting on the inclined plane. Remember, these are not the principal stresses. These are just simple normal stress and tangential stress. Later on in the upcoming session, we will see to derive this type of similar formulas for very more general stresses. For example, stresses acting in the 2 directions, horizontal, vertical, also accompanied by the shear stresses, and then we will derive the similar formulas for them. After that, we will calculate the principal stresses. Now principal stresses is a little bit different than these stresses, but these derivations are very important from our example point of view. So you need to understand the basic concepts. Using the same concept that we have used in this particular derivation, we are going to derive further general case in the upcoming lecture. So we conclude our lecture over here. Thank you.